One of the first problems that every organization needs to solve, whether they're operating on-prem or in the cloud or in some sort of a hybrid environment, is simply understanding what inventory they have, what assets exist within the organization, and then what controls are we going to put in place to try to protect that organization's data. No matter what control framework you're using, it's important that you understand what your inventory looks like. Now, this is spelled out very explicitly in the CIS security controls. Control 1, Safeguard 1.1 says you need to establish and maintain an inventory of all of the assets that can process any of your data, and that includes in the cloud. In practice, I've seen a lot of organizations that really struggle with just understanding what their inventory looks like in the cloud. And so in this video, we're going to talk about a few techniques that you can use in AWS to gather that inventory information. Part of the problem is simply scope. AWS and Azure each have over 200 different services and resource types that you can create. Google, it's still well over 140. And if I don't understand what I've provisioned in those cloud environments, I can't secure it, I can't place controls over it, I can't scope my audits, I can't do compliance work. Nothing is really possible if I don't understand what I have. So one of the very first steps that we're going to take in any organization is simply to develop or to review and make sure that it's accurate, whatever our comprehensive inventory looks like. Now, as an aside to that, when you're doing inventory in the cloud, you really want to consider how the organization is using tagging. Tags are nothing but a name equals value pair that can be associated with a resource. There are a few things that you do need to know when you're doing tagging in the cloud, though. Clouds are case sensitive. So capital B, capital U business unit is different than the same thing with a lowercase b and u. That underscore in the middle matters because all of that is part of the tag name. Because of this, the organization should really develop tagging standards, a policy that says what sorts of tags we're going to have, and standards that say how you're going to handle things like naming and capitalization in those tags. Once you've established a policy like that, you can use tools like Cloud Custodian, which was originally developed by Capital One, but now belongs to the Cloud Native Computing Foundation, to validate that those tags are actually in place on all of the resources that you have running in the environment. In fact, on a lot of our cloud service providers, we can set policies that require that those tags be set whenever a new resource is deployed. So when I'm talking to an organization about cloud inventory, I always bring up tagging and make sure that we make the point that tagging is the thing that's going to make it easier for us to understand who does this resource belong to, who's the data owner, who's the custodian, who's deciding on things like sensitivity and criticality for this resource. Now, when I'm doing my audit and compliance work, I'm simply checking that you're following your own standards for doing that tagging. The way that you gather your cloud inventory will differ depending on who your cloud service provider is. For AWS, it's not actually super easy to do this from the command line interface. I'm going to do a demo where we use the APIs through the command line interface to gather some information, but you'll find that we have to do it resource type by resource type, which is really very slow and tedious. Instead, I recommend a tool in the web console called the Resource Explorer. Now, it was introduced about 3 years ago, and it's matured a lot in the 3 years since 2022. And it's really a very full-featured tool to allow you to quickly gather and then download your inventory for analysis. In Azure, you're going to find your inventory using a tool called the Resource Graph Explorer. Now, it uses a query language called Graph to let you query for the resources that you're interested in. Once you've developed a query that works just fine in the UI, it's going to work out at the command line as well. There are PowerShell modules and CLI tools that allow you to run graph queries at the command prompt, which means once you found that query that works well for you, you could automate it. You could run it daily or hourly and be able to find changes in the inventory very quickly. Google considered changes to the inventory when they were developing their tool. They have a tool called Cloud Asset Inventory that actually maintains a 5-week history and allows you to detect changes in the organization over time. Back in the old days when I was doing audits of on-premise physical systems, I would always ask, hey, what's changed in the environment since I was here last year? Well, now as an auditor, I need to be able to answer the question, what's changed in the environment since last week or yesterday or an hour ago? And Cloud Asset Inventory is really built to help us do that. Now, if you're multi-cloud, or if you would like a tool that's outside the cloud service provider and that can be easily automated, I would suggest that you look at tools like Cloud Query. Now, here I call it cloudquery.io because unfortunately there are a number of tools that took those two words, cloud and query, and put them together into a tool name. Cloudquery.io is the website for the particular tool that I'm talking about here. It allows you to gather inventory into a database. Now, that could be an on-prem database, it could be cloud-hosted, it could be a relational database or a NoSQL database. There are really a lot of options. In the demos, we'll use a local Postgres database, pulling that data out of AWS. The advantage of this is I've now got data in a local, fast database that I can query any way that I want to. If I want to run a full CIS benchmark against my AWS environment, once I've done the fetch of data, I can run that audit in really just a couple of seconds rather than having to do hundreds or thousands of API calls, which could take a while to run. So here are the three demos that we're going to do in this video. The first is we're going to use the AWS CLI. We're going to use that as a way to simulate what you might do with API calls in something like a Python or a PowerShell script, and we'll pretty that data up by using a tool called JQ. Then we'll log onto the web console and take a look at the AWS Resource Explorer. And then finally, I'll show you Cloud Query running from one of my Linux systems in my lab. Let's get started by looking at the AWS CLI. We're going to use it the way that we would have used raw API calls in something like a Python script or a PowerShell script in the old days. We're going to go out resource type by resource type and gather the information that we need. So let's start with something simple like virtual machine instances or EC2 instances that we have running in our AWS account. I'm going to use the CLI to gather information about all of those instances, and then I'm going to pipe it through jQuery just to make it a little bit prettier and more readable. Now that gave me a really big pile of JSON information. Even though this is a really small lab with just a few EC2 instances running in it, I've got a lot of data coming back for every instance. So I'll filter this down a little bit just to the things that I would really care about if I were doing an inventory. And again, I'll use JQ to pretty that up and in fact even to make it look like a regular JSON array. This is not bad. This is really pretty human readable right now. In fact, one of our goals is to kind of normalize reading JSON for humans so that you get used to working with tools like this. If I scroll up just a tiny bit, I can see the beginning of the array. I've got 5 different instances running here, operating systems ranging from Linux to Windows and a number of different instance sizes. I'm able to see the IP addresses and the subnets that are associated with my machines. So I might be able to just export this directly to a CSV, and that would be my EC2 instance information. But I did mention that we might want to consider tags as well. So if the tagging policy is something that you're interested in, you might add the tags into the information that you're retrieving. We'll get the same data for each of the VMs, but now we also can see the tags that are associated. This organization seems to be using a project name and a business unit and a project ID and even classification about things like, well, do we have any protected information in there? So if I were doing an audit, I might consider those tags as well to make sure that they're configured appropriately. But for the purposes of gathering an inventory, okay, that's pretty good information about my virtual machines or instances, but what about the other things that I have running, like virtual private clouds, which are the big network blocks that we create to put our resources into? I would need to gather information on all of those VPCs as well. And within the VPCs, there can be subnets, and so I would want to gather information for each of the subnets. And I would just simply repeat this over and over again until I've got all of the information for all of the resource types that I might be interested in. Now, this could be very time-consuming, it could be tedious and error-prone. Anytime a new resource type comes out or we start using a new resource type, I would have to edit my scripts to make sure that I was retrieving those as well. But for a one-off or for a very beginning inventory, I suppose this is one way that you could gather this information. I just really hope there are better ways that we can do this. The first tool that I recommend to customers for gathering AWS inventory is the Resource Explorer, and it exists inside the AWS Web Console. So I've logged on to the Web Console here, and in fact, I've recently visited AWS Resource Explorer, so I'll just click on the link. Now, Resource Explorer is a replacement for the older Tag Editor, and you can see Tag Editor is still linked here, but it's really not the recommended tool for gathering this information anymore. In fact, when I click on the Resources tab under Explore Resources, I can see that I'm given a list of resources that exist inside my account. And I can very quickly filter this down to the information that I would be interested in. For instance, I may want to find only untagged resources or only untagged resources of a certain type, maybe if I were doing an audit of that tagging policy. Now, I'm interested in seeing all of my resources here to get me a comprehensive inventory, but I'm only interested in those resources that exist in the region called US East 2, because that's where I've got this particular lab set up. So the Resource Explorer actually helps me to build the query by offering values to me as I'm typing, and it very quickly filters the resources for me. If I sort them by resource type, these seem to be the things that I would be most interested in. Now, it's only showing a few per page, so I will change a couple of settings here. Let's show 100 resources and stripe the rows and make it a little bit more compact just so that it's easier to read. Here I can see those EC2 settings. There are the 5 instances that we were looking at in the command line. I can see IP addresses that are associated with them. I can see things like NAT gateways and internet gateways and network access control lists that are associated with them, routing tables and network interfaces and security groups. This feels like a pretty good inventory. There are the 3 VPCs that I saw out at the command line earlier and the subnets that we saw that we've already created. So this looks like a pretty good inventory to me, and I could simply export all of this as a CSV, either only what's showing on the page or all of the available columns, and that could be the initial inventory that I work with in my AWS account. So this is the tool that I would recommend that you go to first, because it's going to give you that very quick look at resources. In fact, what we have found in transitioning to this tool over the past 2 or 3 years from the Tag Editor, which was the tool that we used before, is that we get even more resources showing up in the Resource Explorer. One example would be that we sometimes see resources in here that have been created by the Systems Manager AWS service. Now, AWS is really good at naming their services exactly what they do. Systems Manager is a service that allows you to manage your systems, including your EC2 instances. Being able to see the things that were created by Systems Manager gives me a little bit better view of the inventory, but it does mean that we probably need to talk just briefly about Systems Manager. Because it can be used to manage my systems, it might be a possibility as an inventory tool as well, but there is a bit of a problem. I'm going to go back to the CLI, and I'm going to ask Systems Manager to tell me about all of the systems that it's aware of. So give me your inventory, Systems Manager. And I only get a single system back. That's the only system that I have the agent installed on, so it's the only one that's actually reporting into Systems Manager. Now, on an audit, this might be interesting to me. I would want to compare this data to the full inventory and see if we've got unmanaged systems and whether that's really appropriate for the organization. But it's pretty obvious that Systems Manager is not going to be the place that I could gather my inventory information. If the agent's not installed, or if I'm interested in resources that are not virtual machines, this is probably not going to be the tool to get me there. The last class of tools that we'll look at would be Cloud Security Posture Managers, or CSPMs, like cloudquery.io. If you'll remember, I told you that CloudQuery is going to fetch information from my AWS account and save it into a database, and then I can run queries against that local database. So let's take a look at how we've got it set up. I've configured Cloud Query using a series of YAML files saved inside my config directory for the tool. Let's take a look at the file that I set up for AWS. It's simply called aws.yml. And at the top, I see some version information and that this is a source plugin, meaning it's something that we'll use to pull data into our system. And then we've got a long list of tables. These are really the resource types that I'm going to retrieve from AWS and save into that local database. Now, this This is actually a very short list of resource types because this is a small lab. I know roughly what I have running in the lab, and so I've really stripped down the list of tables. This list could be much longer, and if it were, I would be retrieving even more types of inventory information from the environment. After the tables, I've got a destination. This one is saying that we're going to use a local PostgreSQL database, and then I can see that I've configured a couple of regions, US East 1 and 2, as the targets that I'm going to gather information from. And I've said, hey, if you get new data, then go ahead and overwrite any existing data. And if you've got anything in there that doesn't exist anymore, it's okay to delete it out of the database. That means that every time I do an ingest or a fetch with this tool, I'm going to get a snapshot of exactly what exists in my AWS environment at the time that it was run. And in fact, that's the next thing I really need to do, is to get Cloud Query to synchronize with AWS, pull a list of all of the resources that I have in my environment right now, and write them into the database. Now that'll take just a few seconds to run, and I'll probably see a couple of errors as it runs because the account that I'm using to fetch information from AWS doesn't have permissions for every resource. I don't want it to see things like billing information, and so we'll get a couple of errors and warnings as it finishes up. But that's it. Over the course of just a few seconds, it retrieved a large number of resources from my AWS environment. Now, there's one other thing I'd like to do to get this set up, and that is I'm going to use a SQL view that shipped with the AWS source plugin. This will create a unified view of all of my AWS resources in one, well, virtual table called AWS_resources. To get that created, I need to execute the commands in a SQL file. So I'm going to ask PostgreSQL to run a file that contains the commands to create this view. Again, it executes very quickly because everything is local. And I've now got a view that looks kind of like a virtual table, and it has these different fields in it. So for all of my resources, I can see really what resource type it is because I can see the table it came from. I can see what the ARN or the Amazon resource name for it is. I can see any tags associated with it. So that allows me to gather that very quick inventory information from a single place. I don't have to query every single table because those tables got unioned in to one really large view, and I can simply query that view. So we'll do just a couple of simple queries here. Let's see how many resources got returned. And I can very quickly see that 274 total resources were returned from the environment. Now, you may be thinking that seems a bit high compared to what we got out of Resource Explorer, and of course you would be right. There are a couple of reasons for this. One is I'm querying multiple regions here, US East 1 and 2. And another reason is we're grabbing some things that are actually not region specific, and that would be things like IAM users and groups. And so we will get a number of resources that we didn't get out of Resource Explorer. In fact, I'm going to ask pSQL to show me counts of these resources by region and by type. So we'll just use a group by command, and we'll group by our resource type, which is CQ_table, and by the region, and then we'll sort it by who we have the most resources from. I can see I've got a number of resources from a region called unavailable. These are universal or account-wide resources, and that would include things like my IAM policies and roles, and it would also include things like the users and groups that I have in IAM. In fact, there's even a table that maps users into groups, so I can use that to determine who has what roles in play on the AWS environment. And I can even see things like those EC2 subnets that I created earlier. Those span regions and availability zones, and so we see these in that unavailable region. And then I can see down in US East 2 the other things that we were querying for earlier, like my 5 EC2 instances and the 3 VPCs that we've got created. So the data's in here and it's now easily queryable. I can begin to craft queries that look at the resources that I've got and use that inventory any way that I want. In fact, there are SQL queries that ship with the AWS plugin that allow me to do a full AWS benchmark check of my environment in just a matter of a couple of seconds, because that's now a SQL query running against a local database rather than needing to make possibly hundreds or even thousands of API calls to gather the information to check that compliance. So we've looked at 3 different ways that you could gather your inventory information. Manually from the command line, not really recommended unless you're trying to do a very quick one-off check of a specific type of resource. Using the web UI and then exporting to something like a CSV, or using a CSPM like cloudquery.io to be able to gather all of that information, possibly even from multiple clouds, into one place that could be queried very quickly. If you enjoyed this video, or if you would like to see similar information for other providers like Azure, please let me know in the comments. Thank you so much for watching this video.